Before we can begin discussing polynomial functions and their graphs, we have to first define what a polynomial is. So the definition of a polynomial function of degree n is a function that has the form f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus many terms between potentially plus a sub 1x plus a sub 0. These coefficients, our coefficients are the a sub n minus 1, the a sub 1, and just the a sub 1. Those are the coefficients, and those are real numbers, and they have exponents that are whole numbers. And the largest one, a sub n, cannot be 0. Notice that it's in descending order. However, they do not always appear in descending order, so be aware, because that will change some of the terms that we use and our answers. The leading term, a sub n times x to the n, is the term with the highest power. The term with the highest power, the largest positive power that we've got, since they are all going to be positive exponents. The leading coefficient, a sub n, is the coefficient of the leading terms. We need to find the leading term first, identify the coefficient of that term. That'll be our leading coefficient. That determines some of its behavior. And then last, the degree n of the polynomial is the power of the leading term. So let's look at a few examples. Polynomials are classified according to their degree. And I'm going to write several functions here. We're going to assume that they are all functions. F of x equals whatever follows. So a constant function has a degree of 0. And that might be something of the form f of x equals 3. F of x equals 17. Something that is a constant. Notice there is no variable because it is a constant function. A linear function has a degree of 1. And an example of something like that would be 7x minus 3. We've spent some time with those. Next we have quadratics. Those are degree 2. And those have a highest exponent of 2. So 7x squared, we could have an x term, so minus 8x. And we could have a constant term, plus 1. A cubic has a degree of 3. And my example for that is negative 4x cubed plus x minus 5. Again, the highest exponent there is a 3 because it is a cubic. A quartic has a degree of 4, and my example for this one is 17x to the 4th. They could have more terms, but they don't necessarily have to. As long as the highest exponent is 4, it's a quartic. If the highest exponent is a 2, it's a quadratic, etc. So let's take a function and identify the leading term, the leading coefficient, and the degree, and then we're going to classify this polynomial. So the leading term, we need to look for the highest exponent. So actually, let's find the degree first. The highest exponent is 3. So it is a degree 3 polynomial. The term with our highest exponent is this, minus x cubed. So that is our leading term. Therefore, the leading coefficient is a minus 1. And because the degree is 3, this is classified as a cubic.